Welcome back, learners. As you know, in the previous class we were discussing about finalizing all the beams and column positions as well as how to make your foundation even rigid. So now once all your beams and column positions are assigned and once the foundation is made fixed, the next component that we have to look into it is none other than our slab. Now today in this video let us learn how to first define our slab, and once the slabs is defined, then how we have to assign them or how we have to place them in for our given project. So now in order to define our slab, we have to again go to an option where as we previously defined our beam and slab, so there itself again we have to go to define. But in the define, again there is no need to specify any material or no need to define any material, because in the previous video itself or in the beginning lectures itself we have finalized that our beam and slab will be made up of concrete, and the grade of concrete for both our beam and slab will be same, that we are using M20, whereas for the columns and footings only we are using M25. So therefore no need to define any special material property. But when it comes to the section property, even slab is also your section, but when it comes to the section property, what you are supposed to do here is you are supposed to go to the slab section, because when you want to define your beam and when you want to define your column, we are going for the frame section. Okay, and already we discussed when you want to define any tendons, that is when you are designing the bridges, so where we use a tendons, there we go for the tendon section. When you want any slab, then we have to go to the slab section. When we want to define any deck, that is for the bridges, then we have to go to the deck section. And when we want to define wall, we have to go for the wall section. So since we are defining now slab, I have to go to the slab section, right? Again, when you click on the slab, so we need to have a new slab. You can delete these two slab. Okay, you can delete. So you want a new slab, so let us go to the add a new property. So when I click on add new property, so what I will do is I will give the name as slab. Okay, usually what will be the thickness of the slab that we give? Usually if you say it in terms of engineering units, the minimum slab usually we maintain, okay, the minimum slab that we usually maintain is 100 mm, whereas the maximum slab that we usually go is 200 mm. But for any optimum residential building, so usually we give an slab thickness of 120 to 150 mm. We give an slab thickness of 120 to 150 mm. So for our project, let us assume that we will take up a slab of 150 mm thick. When I am taking a slab of 150 mm thick, it means it is almost 5.9, that is 6-inch slab. So therefore let us give the name as property name as a slab of 6 inches. So let us give like this, a slab of 6 inches, that is my property name. Then as I already told, my beam and slab, they will be casted monolithically, that is at a time, one time only we are going to cast them. Therefore whatever the material we used for our beam, so the same material also we will use for the slab. Therefore for the slab I am using M20 grade of concrete. After that, next, once you give the property name, once you give the slab material, no need to change this modifier or display color or property name, but this modeling type is most important. You can see when I click on this modeling type, you have 4 options, that is shell thin, shell thick, membrane and layered. So then which one you have to use, or what is this meanings indicates? Shell thin, shell thick, membrane and layered. See students, usually shell thin Okay, usually when we are going to use shell thin is if you are defining any water tanks. Okay, if you are designing any water tanks, in such times we usually go for shell thin. That means we make those material, or we assume that as a thin material. Okay, so by making this as thin material, usually when we are designing any water tanks in the AutoCAD, sorry, in the ETABS, we go for that as a shell thin. Okay, so when we use shell thin is we assume that there are some hoop stresses. You may be knowing what do you mean by hoop stresses. Okay, so whenever you have an hoop stresses, that is hoop stresses is present only when you are defining the circular water tanks. So therefore when you are defining or designing circular water tanks, you need to consider that some hoop stresses are present on the wall of circular water tanks. So that time those also they are considered as slabs, they are not considered as walls, because they will be made of concrete with the reinforcement. So that's why we cannot make them as walls. If it is considered as wall, then it has to be usually constructed with the bricks or the hollow blocks. So your water tank walls, that it may be a circular water tank or maybe a rectangular water tank, they are not usually built with the bricks or blocks. Either it will be made up of reinforced concrete sections. So that time we have to, there will be a presence of hoop stresses due to the presence of water inside that. So that time we have to model the slab as shell thin. Then what about this shell thick? What about this shell thick? Now when it comes to the residential building, okay, when it comes to the residential building, sometimes the slabs are casted separately, or they are designed in such a way that the loads from the slabs will not be transferred to the beams. Okay, it will be designed in such a way that your whatever the loads on the slabs is there, that loads will be taken care by the slabs itself. So that time we go for the shell thick option. Okay, that time we go for the shell thick option. But in our day-to-day life, we design the structure in such a way that whatever the loads on the slabs is there, that will be effectively transferred. It will be taken care by it, and it will be effectively transferred to the beams. So from the beams it will be effectively transferred to the columns, and from the columns it will be effectively transferred to the footings. So in this way we are designing this. Okay, so therefore we are going to design it as a membrane. So therefore we are supposed to choose the modeling type as a membrane. Okay, we are supposed to use modeling as a membrane. So once you choose the membrane, if you choose shell thick or if you choose shell thin, here there will not be any appearance of an option, or even layered also it will not be considered. But if you choose membrane, you can see that use special one-way load distribution. It is asking you if you are making it as a membrane, that will be an one-way slab or a two-way slab, or you want to distribute the load only in one direction, then you have to choose this. That means it will be your one-way slab. Now usually we always define as a two-way slab, because if you are making as one-way slab, so usually the thickness of the slab will be increased, and even the reinforcement required is also increased. So that's why usually when you have a more number of slabs, we usually define them as a two-way slab. So therefore no need to choose this option. You just make it as membrane, and you make this as slab material you choose, give the property name. That is all about here. Then here you have to give the type. Again you have slab, drop, drip as waffle. So these are the different types of slabs that you can have. Okay, so when we take up another problem, there I am going to explain you about the drop slab, as well as the ribbed slab, as well as the waffle slab. Everything will be explained. Okay, everything will be explained. So here we are, for the first problem we will be making the slab as a normal slab, therefore we will give the slab, and we have to give the thickness as already told. 150 mm is my thickness, that means almost it will come 6 inches. Directly it is there, it will be a slab of 6-inch thickness. So therefore I have given the property name slab, I have given the material, that is M20, then I'm going to modeling it as a membrane, then I want the load distribution in both the sides, then I'm making the slab as a normal slab, then I'm giving the thickness as 6-inch thick slab. So once all this data is given, you just give OK. So then you will get a slab here, even you give OK. So now my slab has been defined. It is not at all assigned, nowhere it is assigned, it is just defined. So once the slab is defined, then you have to assign the slab. So where you have to give the slab, you can make sure that the slab is given to this floor and the slab is given to this floor. There is no any slab here because it is at the ground level, that is your plinth beam. So here the soil will be present, therefore the slab has to be given to only this and only this, right? So now let us start giving the slab. Even while giving the slab also you can go for the 1 story, because I don't want the slab to be present here, therefore I'll just apply the slabs story by story, right? So let us keep the display, let us keep it in the plan, and let us start from the story 2. I'll give OK and I have to keep it as 1 story. Then now I have to start assigning the slab, right? OK. Now I have to assign the slab. Now you can see here I can draw slab with the help of this. Draw the rectangular slabs, or you can draw the floor or wall, that is you can draw it in plan, elevation or 3D. If you are choosing this, you can draw the slab only in the form of rectangle. Okay, so if you have only the rectangular slabs, then you can draw that. But if you want to have some other slab designs also, you have to go, you can see it is exactly in the form of rectangle. If you are drawing only rectangle, you can use this option. Okay, but if you want other than rectangle, you can choose this. There again I have to choose from slab 1. My actual slab is slab of 6-inch. I have to choose this. Okay, now the first and foremost thing, now I have to apply entire this portico slab. Okay, so we cannot give the slab from this corner to this corner and from there to here. No, it is wrong. The slab will not be casted like this. So the slab will be casted from a portion to portion value. Therefore, what you are supposed to do, first let us cast this slab, that is from here. Okay, so here to here. Okay, so this is my first slab that I have casted, right? So then after that, make sure here that this is a cantilever portion. The cantilever portion slab will not be casted separately. Okay, it will be casted along with the previous slab. Therefore what we will do, this entire thing we will cast once. Therefore I will start from here, 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 here and here. So this is my second slab that I have casted, right? So once this is done, what I can do, I can entirely cast this portion. Okay, this will not be casted, this will not be separately casted, this will not be separately casted. Usually this entire will be casted. So therefore what we can do, we can cast from here to here, then I can directly go on this here to here, then here to here, here to here, here to here, finally here. So that is my second slab. You can choose like this. If I choose, the only this slab will be chosen. If I click here, you can see this entire slab will be chosen. Now if I see here, you can see this entire slab like this it will be chosen. Okay, yes. So then after that again this entire slab can be casted. Okay, they don't cast this separately, they'll cast this entire slab. Therefore what I will do, I'll just cast from here to here, then from here to here, then from here to here, then finally here. Okay, therefore now if you choose, you can see this entire slab will be casted. Okay, then after this, you know that there is no any slab here, so I have to place the slab for this portion. Therefore again I will place the slab here, here to here, then here to here, then here to here, then here to here. Okay, so that is my this slab. Then after that what I can do is, now here usually this slab will be casted because I need this one slab. This is for a particular commercial complex. Therefore this slab I will cast, then this slab I will cast. Okay, so therefore what I will do, here to here, then here, then here to here. So this is one slab. Then from here to here, here, here to here. So this is the second slab. So you can see this slab is casted separately, this slab is casted separately. Then after that you can see here there is no slab here because this is for your staircase. So therefore no need to give the slab here, but here you can give the slab because this is the last floor. Above this there is no any other floor. Okay, there is no any other floor, but initially till we complete our design of staircase, no need to give the slab. We will give the slab later. So therefore this will be casted together because I have a cantilever portion, and this, now sorry I just made a mistake, this entire thing will be casted once because this is again my cantilever portion. So this entire thing it has to be casted. So therefore let us delete this. Okay, I will cast from here to here. Okay, from here to here this will be casted like this. Okay, this one. Then I have to cast from here to here, 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 then here, right? Yes, so my slab is casted for the first floor. Now let us go to the second floor. Here also now I have to do the same manner. So let us start doing. First will be this part, here to here, here to here, here to here, this one, then from here to here, 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 right? Then I already told we are going to cast like this. So therefore let us start from here to here, then here, then it will come to here, it will come to here, here, here. Okay, so that is my second part. Okay, that is my second part. Now here to here, then here, then here to here. Okay, then this part, then this part. Okay, so that is from here to here, from here to here, here to here, here to here. So that is this part. Then this, now what I can do, you can see here, so there is a separate room for this. So therefore this entire thing I will cast, and this entire slab I will cast. So therefore what I will do, I will cast this slab from here to here, here, here to here. Then I will cast from here to here. Okay, because if you see the previous this one, so I was not having any beam here. Okay, so therefore I casted this entire slab, but here if you see the previous one, so I am having a beam, therefore what I will do, I will cast this area, then I will cast this area. Okay, so then finally I have to cast this slab here to here, 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 here. Okay, so my slab is casted. So now I am not supposed to cast any slab here because it is a plinth beam. It will be at our ground level. Okay, so therefore if I see, this is how your slab looks like in the 3D form. Okay, right, like this it is going to look, slab. Is that clear, students? Yes. Okay, so this is how your slabs looks from the front. Okay, I can even make it to plan also like this. You can see this is our slab. Okay, yes. So why this line is coming is, it is not exactly rectangle in shape. Okay, that's the reason this line is coming, right? Okay, so this is how my slabs looks like. You can see here in the cantilever, it is a cantilever slab. Okay, yes. So even you can see the slab here also, this side also you can see the cantilever slab. Just a minute, students. Yeah, this is slab. Okay, yes. So this is how your slabs looks like. Right? Okay. So once the slab assignment is done, okay, once the slab assignment is done, so our next step is to apply the loads. Application of the loads is very, very important. Right? So before application of the load, there is one important step that we need to follow. We call that as application of the diaphragm. So now you may see that what is this diaphragm or why it has to be applied. See, you will be clearly knowing about your center of mass and your center of stiffness. Okay, now why the application of diaphragm is required here is, see, the software will consider each and every slab as an individual element. Okay, usually it consider each and every slab as an individual element, but for us, when the design is going to be done, we are not going to design each and every individual element separately. We need the entire structure to be designed. Okay, so therefore what we do is, when the diaphragm is applied, so what will happen is, each and every corner of the slab will be held in one particular point, which we call it as the center of mass. Okay, and by doing that, what will happen? So the software will again consider that no, each and every slab is not an individual element. It has to be analyzed at a time. If you are not applying the diaphragm, then what will happen? The software will consider each slab as separately and it will be designed separately. So since in order to avoid that, we have to apply the diaphragm to the floors. It is applicable only for the slabs. It is not applicable for the beams or for the columns. So then how to apply diaphragm? You keep your structure in the plan, and again keep it in mind, it has to be applied only to the slab. It should not be applied to the foundation. Therefore we cannot make it all story, we will keep it one story. Then what I will do, I will select my all the slabs. Now you can see here my all the slabs has been selected. Right, if I do like this, what will happen? Even your beams will get select. Even your beams will get select. I don't want the beams to be selected. Okay, so therefore what I will do, I will just select only the slabs. I need diaphragm to be applied only to the slabs. How to apply the diaphragm? So for that you have to go to define. In the define, you can see first is material, next is section, next is spring. The fourth option what you have called as diaphragms. So in that you can see add a new diaphragm you can give, or even you can give modify or show diaphragm, right? So there we will keep the name as D1 and rigidity will be rigid. We are making all the elements of my structure to be rigid, not semi-rigid. It has to be rigid. So therefore I will give OK, no need to change, right? Then I have to select my slabs in this floor and in the previous floor. So therefore what I will do, I can either select this like this manually, I can select like this manually, or I have one more option, what we call it as select. So go to select. In that you have to select the given slab. So in order to do that, I have to select by properties. So go to properties. In the property, I have to choose the slab sections, not frame sections. I need only slab to be selected. Therefore I will give slab sections. In that, which is my slab? My slab is slab of 6 inches. You select this and you give select. Okay, then close. Right, you can see here my slabs are selected. No, just a minute. Right, yes. So go to select, go to properties, in that slab section, go to this, then select, then close. Now you can see my all slabs has been selected of only the second and first, that is here and here. Then after that, once the slabs are selected, go to assign. Okay, so go to assign. In the assign, I have to go to shell. Okay, I have to go to shell because diaphragm I already defined here. Define. So diaphragm already it is defined D1. So now I have to assign. Therefore I have to go to assign. So in the assign, go to shell. Shell means slab. Okay. So in the shell you go to slab sections and all already we have done. Now I have to apply the diaphragm. So give diaphragm. In that choose D1. Choose D1. Give apply and you give OK. Now we can see that my entire slabs, all my corner slabs will be connected and it is made to be present at the center, making everything will be analyzed and designed at a time. That's the reason we have to apply the diaphragm. You can see from the plan also. When you see from the plan, you can see that all my corners of the slabs has been connected like this. Okay, so we made the structure rigid. Okay, we made the structure rigid. right? Once the diaphragm is applied, then our next step is application of the loads on the slabs. So how to apply the loads? So let us see that in the next video by considering the IS 45 by considering the proper IS codes, because we have to apply the live loads and we have to apply the dead loads separately. So that let us see in the next video. So if I want to summarize this today's video, so what we have done, we have defined the slab. After defining the slab, what we have done, we have assigned them by structure. So once it is assigned, then we have defined the diaphragm and we have assigned the diaphragm. Even I explained why the diaphragm has to be applied, right? So in the next video, so let us learn how to apply the live loads and dead loads as per the IS codes. Thank you, learners.